Hey guys, today I'm going to show you how to integrate Azure Mobile Services with the Service Bus. So the Service Bus is actually a really useful service. It allows you to create really massively distributed systems at scale with durable messages. And so I mean by durable is that these messages won't be lost, they're very reliable, and it's not like push notifications where sometimes you might get and sometimes you might not. So really what it looks like is you have a lot of producers that actually push this queue in the cloud, and then you can consume it from anywhere. And this queue is in the cloud, so anything can access it. So what's really useful is like things like Internet of Things devices, which are very small. You could think of like your refrigerator that can have a chip that when the door opens, it sends a message to the cloud, and then it could trigger your application to do something. So let's get started. So first you're gonna need a mobile service. So we'll go ahead and add a new one. We'll call it Azure Service Bus Demo. And then go ahead and enter a password or create a new SQL database if you need to. I'm just using my same one that I have. And you're also going to need a service bus. So go ahead and scroll down to the service bus tab on the portal. And you want to go ahead and just create a new one. We'll call this Mobile Service Bus 2. There we go. After Service Bus is created, go ahead and grab the connection information. This is going to be the root connection information string. You could choose to use more different type of string that has less access privileges, but for this demo, that's what we'll go ahead and do. Go back to your Mobile Services tab, and what we'll do is we'll take that key and we'll enter in our configuration so that we could use it later. Call it Service Bus Connection String. Go ahead and save that. Since we always want to enter, listen to Service Bus consistently, we're going to make a scheduled task. We'll create a new job here, call it Listen for Messages, and we're going to run this once every minute. One last thing, you're going to head over to your dashboard and you're going to look for Setup Source Control. Go ahead and click that so that we can make a Git repository. That's going to allow us to extend our Azure Mobile Service to add different packages in Node. After that's done, you're going to go back to configuration page and you'll see that we have a Git URL, which is the repository for our code for this Azure service. So you're just going to do a normal thing. You're going to go ahead and go to your Git console and just clone it. You might have to enter your credentials as well, but afterwards you should just be fine. And so now if you go to your service Git repository and you go into the service folder, it's the only folder that's in there, you want to look at the package.json. And if you're used to NodeJS, you know that npm adds these automatically. What we'll just go ahead and do is add this Azure 0.8.x, just means version 8.8.x. That's the current version right now. And it'll tell, once you actually push back up to Azure, it'll tell Azure that it should install the Azure module. So after you do your commit, you do the commit and you do the push, adding Azure module. And if you do this push, you'll see that npm will start to run after the commit on the server where the Azure module is installed. If everything happens correctly, you'll see that this deployment finished successfully, and we'll be good to go. So generally what I like to do is open up the service folder in like Sublime or my favorite text editor. And if you go into, if you look here, we have the scheduler folder. Ooh, sorry about that. Here, we have our scheduler folder. And in that schedule folder, we actually have a scheduled task. And what we want to do is go ahead and add our code that we need to actually start listening to Service Bus. So the first couple of things we need is we obviously need to import the Azure library that we have. So we're going to require in the Azure. And also we want to make sure that we specify, we'll use this timeout later, but it's to basically specify how long this actual scheduled task is going to run for. Afterwards, we're just going to grab the, we need to do a couple of things with the time because we listen to Service Bus for a certain amount of time, we need to know exactly how long we're going to run, or else we'll keep the task running after the schedule is over. So we want to make sure that we kill whatever we're doing. So if you remember in our configuration settings in Azure, we set this value in the configuration service bus constraint. And what we'll do is we'll go and grab it from the process variable as an environment variable so that we don't really have to keep it in the code. We just kind of pull it in. And we'll do that to use this create service bus service API in the Azure module, which gives us our service bus client. I'm going to define a function here called listen for messages, which will listen for a message for a certain amount of seconds. And inside it, we'll go ahead and call the service bus API receive key message, which allows us to listen for a message for for a certain amount of time in timeouts. And I believe the maximum timeout is 90 seconds, so any larger than that. One thing I forgot to mention is that you have to make a service bus queue. So the queue within the service bus. So you just go inside your service bus tab in the portal and click create new queue. And just do a quick create. And we'll call it mobile service as the name of the service bus queue. You want to make sure that the name of the queue matches what you have on as the first variable for this API. And what's going to happen is it's going to try to listen for messages for the defined number of timeouts. So what I'm going to do inside here is I'm going to actually just go ahead and check to see if we got an error. And if we didn't get an error, that means that we did receive a message. And if that's so, then we could just go ahead and output the text of that message. So I'm going to expect a JSON object coming through the wire. And what to note is that the body object within the data object here, it's going to be a string, so it's just a raw string, so you'd have to parse it. And depending on if the person who sent the message sent JSON, this will succeed. So if you're not expecting JSON, if you're using XML, something else, you should parse it differently, obviously. And otherwise, I'll just go ahead and just log that no messages to receive. And actually, I believe the error object says that, so we could just leave it as log the error. Okay, and that's great. So we could say that we're done here, and hey, we've connected Service Bus to our Azure mobile service. But the problem is that if we receive one message, we'll have to wait at least 1 minute to receive the next one. So we can't operate any faster than once a minute, which is pretty slow. So in order to kind of speed that up, what we could do is we could just go ahead and call listen for messages again. But the problem is we can't just call listen for messages just like like this, because if we did, then we would just be continuously calling ourselves, and this scheduled task would never end. And what will happen is that Azure will start another instance and another instance of the service until it starts n number of instances that all never end, and your process time goes through the roof. And eventually Azure will just stop your service and your app will stop. So that's actually not good, and it's not obvious that that's how it kind of works. So what we're going to do instead, we're going to create a new function called create continue received messages, and I'll just go ahead and add it. I actually pre-wrote the code here. And it's not exactly obvious that you need to do this, but what needs to happen is you need to use this start seconds here, right up here, just to see when did you actually start running? When did this service schedule actually start? And if we still have time left before the timeout, so we have 1 minute before the next service, the next scheduled task starts, continue listening for messages. But if you don't have any more time, then you should just not keep running and we should just stop. So this function just basically does that. It just checks to see if we have enough time left. If we do, then it runs this function again with just a smaller timeout. And if the timeout is less than 0, if it's negative, then that means that we've ran out of time. And so we just don't run anymore. So yeah, change that to greater than 0. There we go. I'll go ahead and make sure we call our starting function, listen for new messages. And we'll go ahead and use the timeout value that we have up here, the constant timeout. And we're going to make sure we call the continue receive messages to ensure that we continue receiving the messages that we need. And that's basically it. So this will continue receiving the messages, and I'll go ahead and show you the output that you get on the logs. Make sure that you commit your code to your repo, adding Service Bus integration, and then just go ahead and push it. And Azure Mobile Services will go ahead and just launch the new service seamlessly after you do the push. One quick note, make sure that you enable the actual service so it runs. And what I've done here is I've created a NodeJS application that uses the same library, the same Azure libraries you use in the cloud, and it just uses the send queue message function instead. And what we'll do is we'll just send messages over and over with this, this JSON object here. And notice that I am making it to string because this function takes a string and not an object. So you can see that my Node client is running. That's actually sending to the service bus, and you can see that we're getting the receive message from embedded device here, and we're actually sending the message here. And that's how it works. So from this point on, you can do a lot of things. You can actually connect to push notifications, or you can connect to your installed apps or your websites to kind of show the status of very far different devices or embedded things that you're doing, and really kind of create an Internet of Things connected experience easily just right on your own.